Hi there, are you tired of your old sauce being barbecue sauce? We have the product for you, as we like to call it, the mathematical sauce.
How many vegetables do you eat daily? That is unbiased. You can say 0. And D, don't you agree that schools should offer more choices for foreign languages? So this part, you know, you might be kind of scared, and so that would be a biased question. Match each study with a study type being used. Remember, observational study is just whatever you observe. Experiment is something you do to them, and a survey means you give them or you ask or you give them something. Okay. 3A. To determine whether the patrons of a local fitness center like new exercise equipment, the owner asks a random sample for their opinions. So if you're just asking someone for their opinion, they're just going to give you their opinion, right? So that would be A. This one is A. A florist, let's write that, giving their opinion about gym equipment. Okay. B. A florist is testing a new plant food that should allow fresh cut flowers to last longer. She randomly selects half the cut flowers and applies the plant food and records the results. So she's doing something. She's only giving half the flowers this new plant food. So she's giving or doing. That would be B. Florist gives new plant food. And that's why it's an experiment. She wants to compare, right? Does that stuff actually work? Okay. C. Researcher observes toddlers playing with a newly developed toy and record the reaction. So they're just watching. So that would be C. Watching toddlers to see reaction. Keyword there is watching or observing. A random number generator was used to select a number from 1 to 8. A number was selected 120 times, and the results are shown. Complete the statement below, round to the nearest 0.1% if possible. The experimental probability is basically what happened up here when you ran the simulation, when you actually did it. Okay, so we wanted a 7, so that would be 18 of them, and our total is 120. Again, you can just add all those up and you should get 120. So 18 divided by 120 is 0.15, and multiplied by 100 you get 15%. So in theory, 7 should have only came up 12.5% of the time, and then actual, or in our experiment, it comes up 15% of the time. All right, promotions. A special message is written under the cap of each bottle of Rossio's famous root beer. There is a claim that 1 in every 20 cap wins a prize. Identify the simulation that can accurately test the claim. Okay, so I need something that can equally give me 1 out of 20. And 1 out of 20, you can multiply by 5 and you'll get something like this. You'll get 5 over 100, so that is 5%. Okay, so let's take a look at this. Let's go D. Use 2 dice. Tossing 2 6s represents a winning cap. Well, if I need 2 6s, this is only going to come up once. That's a double, so that's 1 out of 36. So that's a no. And then question C says use 20 marbles. 5 are red, 12 are green, 8 are blue. Choosing red represents a winning cap, and all other colors represent non-winning colors. Okay, so 5 represents 5%. So this one would be good. No. That's wrong, because there's only 20 marbles. So that represents 25%, which is wrong. Okay, let's try B. Use a random number generator with the numbers 1 to 20. A selection of 1 represents a cap, and all the other numbers represent non-winning numbers. Okay, that one looks good. And let's just double check by doing the last one. Use a spinner with a red section that is 20% of the area. Okay, so 20% is not the same thing as 20 here. 20% represents 20 out of 100, and ours is 5 out of 100, so that would be wrong. So hopefully you caught those mistakes just like I almost missed it. So B is our correct answer. Number 9, calculate the mean and standard deviation for the dataset, round to the nearest tenth if necessary. Okay, so I'm going to take those numbers, and if you have your phone or graphing calculator, I'm just going to punch those in. So the calculator commands are stat, edit, go to the top of your list, press clear, and then clear, then enter, then they go away. Okay, let's go ahead and input all those numbers. 16, 18, 23, 17, 15, 22, 21, 19, 26, 17, 14, and 18. I'm gonna press stat, calc, var stats, and it's already on list 1, so that's the default, which means you don't have to press it, so you can just press enter. And here the X bar is 18.9, and then the standard deviation here, double checking I have my numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Uh-oh, I only have 11 numbers. Oops, I did it again. 16, 18, 23, 17, 15, 22, 21, 19, 26, 17, 14, and I forgot the last one. Stat, calc, var stats. Okay, X bar is 18.8, and our standard deviation there looks like OX is, because we have all the numbers, it's not taken from a sample, so it's not SX, that would be a sample. So this would be 3.38 or 3.39. Let's write that. So that was X bar, and this one was the population. Standard deviation, again, because you have all of the numbers. This does not come from a sample. Like if I had a class of 40 students and then I say how many M&Ms can you eat in 20 seconds, right? Without choking or something. Classify each random variable as discrete or continuous. Okay, so I'm looking at my formula sheet, which is basically a condensed version of my my notes, and I wrote that discrete means you do a count, and continuous just means can be any number, like a decimal or fraction. Okay. 13. A number of visitors to a website each hour. So a visitor is a whole person, so that would be discrete. Level reached on a video game. Well, a level, you can't go to level 2.7a, you can only go to like level 2 or level 3. So that would be also discrete. Spelling. Miss Karuma Gave a spelling test to her second and third period Spanish classes. There were 20 words given, and a number of correctly spelled words are shown in the tables. The average score is higher for which period? So average score again is your average. And then the scores were more varied. Varied means variation. And that would be our standard deviation. So I'm going to go ahead and put in both those lists. We'll call this one list 1 and this one list 2. And there are 16 students in each class. So let's just put this like a chart. And I'm going to have the average, should be actually the mean of that one. Because you have the whole population of the class, and then the standard deviation. All right, let's go ahead and pump in these numbers into the list. Clear, stat, edit, list 1. I'm going to press clear, enter. And then every number I'm just going to press 20, enter, 10, enter, 20, 15, 18, 18, 19, 20, 14, 17, 18, 19, 16, 14, 16, and 14. I'm going to go up to list 2. I'm going to press clear, then enter, and then enter those numbers for period 3. I'm going across 19, 8, 20, 10, 12, 17, 20, 16, 18, 16, 18, 18, 17, 14, 12, and 19. So I'm going to press stat, calc, one var stats. Remember, if I press enter, this is the average. I'm sorry, this is for period 2. So 16.75. Write that down, 16.75 and 2.73. Okay, so I got that information down, and then I'm going to press stat, calc, one var stats, and then I'm going to put in list 2. So that'd be second, number 2, second, number 2. And this would be a 15.88 in the SOCS, which is your population standard deviation 3.53. Okay, so if I go back, whoops, wrong one. And 16.75, 15.88, 2.73, and 3.53. All right, so which one had a average that was higher? That would be 16.75, so that would be period 2. And then which one has more variation or higher variation? A higher variation just means a higher, and this would be period 3. All right, let's go over this question. The test scores from students in a physics class are shown: 93, 82, 70, 88, and 81. So there are 1, 2, 3, 4, 5 scores. And the mean is the summation of those numbers divided by n. So 93 plus 82 plus 70 plus 88 plus 81 divided by the 5 students in the class, you will get 414 divided by 5, which gives you 82.8. X bar is equal to 82.8. Okay, so in the formula, standard deviation is equal to the square root of the summation of the data points subtracted by the mean. Take those values, square, and divide it by n, and then take the square root. Okay, so I'm going to write down those 5 numbers. So I have 93, 82, 70, 88, and 81. Just go ahead and repeat those numbers. And then we're going to subtract it by 82.8. Some of your numbers will become positive, some will become negative. Okay, so when I subtract these two values, I'm going to get 10.2, negative 0.8, negative 12.8, 5.2, and negative 1.8. Okay, this was a common mistake. So the values have, the difference of those values, or they call them deviations, the deviations have to be squared. They have to be squared. So what that means is I'm going to take the value and put it in parentheses. Here, you'll notice that all your values will become positive. All your values will become positive. That was a common mistake among students, not writing down the formula and then okay, so all these values now, you're going to take the summation. So I'm just going to add these values here in blue, and you get a grand total of 298.8. Okay, now I'm going to divide it by 5, which is my n value. So if I just divide it by 5, I still need to take the square root. I'll get 298.8 divided by 5, 59.76. And when you take the square root of that number, you will get, so this is summation, standard deviation, 7.73. I think I got 7.8, so I wonder if this number is incorrect. Let me double check. 59.76. I mean, the answer should have been 7.73. All right, so this is finding standard deviation by hand. Our normal distribution has a mean 74.8 and a standard deviation of 4.5. What is the percent of the data that would be less than 83.8? Always, always, always in math, draw a picture. So here's my picture. And I'm going to go ahead and draw the center, 74.8. And it says it wants 83.8. Okay, where's 83.8? It's got to go to the right, right? Because this is like, I don't know, 0, and this has to be like 1 million on a number line. So that tells me I kind of need to keep adding 4.5 to the right. So let's see if this hopefully lands to empirical rule, and if not, then I have to use a z-score and use a table or use our graphing calculator. So let's go ahead and do that. So let's go ahead and add 4.8 or 4.5. 74.8 plus 4.5 gives me 79.3. Not bad. All right, let's do it one more time and see if we get lucky. Yes, yes. I'm so happy because I don't have to use the table. Okay. So let me just mark off the other areas. Pencil, come to me. Okay, so it doesn't matter really what these two scores are, but I just want you to hopefully... Okay, so from the center, this is 1 standard deviation away here in yellow. This represents in the empirical rule 68% of the data. Okay, pay attention. Now, the green area combined represents this direction. It represents 95%. Are we okay here so far? Okay, so it wants to know what percent of the data will be less than 83.8. So let me go ahead and just draw a picture here. It wants to know all of this. Okay, so let's get another color. How about this blue here? We're trying to find one of the tails, and we already kind of found the answer from the other one. So watch this. So if this is 95%, 2 standard deviations away, that's the whole green area that includes the yellow. So that's 95%. Let's just, yeah, 95%. That means this area would be like an X, and this would be an X. So you can technically do X plus 0.95 plus X. And remember, a total probability distribution equals 1. So if you combine like terms, I get 2X plus 0.95 equals 1. If I subtract the 95 from both sides, I get 0.05. And if I divide by 2 on both sides, I get 0.025, which is 2.5%. So each of these X's here represents 0.025. 0.025. And so basically what I'm doing here is I'm adding up 0.95, because this will represent the red region. And if you add those up together, that's a plus. You will get 0.975 or 97.5%, which is letter choice D is my answer. All right, question number 16 says, what is the value of Z? So that means they're asking Z is equal to what? If you know the X, standard deviation, and the mean. So the formula, if you look back, Z equals X minus the mean over the standard deviation. And you just substitute in these values. So X goes there. .6 minus our standard deviation is 2.8, and then the mean is 9.2. So if you put that into your calculator, 38 minus 6, let me grab my calculator here. And you divide that by 2.8, you'll get 10.5 as your answer. All right, question number 17, screens. Charlotte surveyed 420 chosen students at her school, asking how many hours they spent looking at a screen during the week. The average time spent was 24.8 hours, with a standard deviation of 3.9. Use a 95% confidence interval to find the maximum error of the estimate of time spent looking at a screen. Round your answer to the nearest hundredth. Okay, so let's highlight some information here. I see n equals 420. I see the mean here is 24.8. I see that the standard deviation of the sample is 3.9, and I see a 95% confidence interval. So if I look back at my notes, the first thing that I probably want to do here is write down a formula. To find the maximum error. This is E, or another way of saying is margin of error. So the formula is E equals Z times S divided by the square root of N. Okay. To get Z, you're going to have to use the 95% confidence interval is you're going to get a z-score of 1.960 from our notes. Okay, so I'm going to use this one for that value. So E equals 1.960. The S is 3.9. And the N value is 420. Don't forget the square root. And remember, to make this side a fraction, you just put it over 1. So essentially it is 1.960 times 3.9. I'm gonna take a picture and I'll do that with you so you can see that step by step. Okay, so go to my calculator. I'm gonna type in 1.960 times 3.9 divided by the square root, which is second, and then up here by the 7 is in orange, the square root 420. And press right key to get out, and then close the parentheses. And that gives me an E value of 0.372, and it tells us round to the nearest hundred, so 0.372. 0.37. So we can say with 95% confidence that the mean time spent watching a screen per week is 0.37 hours of the sample mean time. So we're pretty close. Break room. A business has surveyed 154 chosen employees, asking whether they supported removing the soft drink machines from the break rooms. A total of 28 people responded that they agreed. Okay. So this would be my X, right? And using a 95% confidence interval, which estimates the population proportion. Okay, proportion should give you a hint that it's a fraction. It's a fraction. So let's get all of our variables. So the proportion I need is p hat is your x over n. So my x is the 28 and my proportion or n value is 154. Okay, so q hat is basically the complement. So if you took 154 minus 28, you'll get 126. So basically 28 plus 126 will give you the 154. So if you divide 28 divided by 154, I get 0.18. Okay, so another way of getting q hat is equal to 1 minus p hat. And if p is 0.18 from above, 1 minus 0.18 gives you 82. That means q hat is 0.82. And you'll notice these numbers, p hat plus q hat equals 1. Okay, so we got a bunch of variables. Okay, let's get a well, we wrote down all the steps. Sorry, estimate a population proportion. The first thing we should have done is check the conditions. And the best one is, we didn't go over this one, but in AP Stats, we would have used the acronym RIN. Is it random? Is it independent? And is the N value is n value greater than 0.10. All right, the conditions we needed is n p hat greater than or equal to 5 and n q hat greater than or equal to 5. And if n was 154 times p hat, 0.18, is it greater than or equal to 5? And then same thing over here, 154 times q hat, which was 0.82, is that greater than or equal to 5? And if I just punch those in my calculator, 154 times 0.18 gives me 27.72. And then 154 times 0.82, 126. Okay, so the conditions are met. It is big enough sample size. Second one is, which we just did, the p hat and q hat. Okay, third step is we need a confidence interval. So a confidence interval of 99%. If you look at your chart from your notes, it gives you a z-score. And a z-score, the IC is 2.576. Okay, the fourth thing we need is the formula. That's this formula. E equals z times the square root of p hat times q hat over n. Now, if you get confused on this formula, I want to break down something. You can do the square root of p hat times square root of q hat over the square root of n. And that actually looks like our formula for finding the population mean. Okay, so let's just punch away in our formula. I need a z-score, which we got way over here. And let's just write that. E equals 2.576. Okay. Times our p hat value. Whoops. P hat is 0.18. And our q hat is 0.82. All over, because remember this is like z, you can make it a fraction by putting over 1. And then you still have the square root of n value, which is 154. All right, let's take a picture of this. Okay, so again, trick here is alpha y equals, gives me a fraction, n divided by d is numerator divided by denominator. And then I'm gonna get 2.576 represents my z-score, open parentheses, square root, so that would be second x squared, and then 0.18 times 0.82, close parentheses. Click right, and then down, and then second x squared to get square root 154. Exit out, and then press enter. I get 0.079. 0.079. So if I round up, that would be 0.08. Okay, the fifth thing I need to do is now calculate the population proportion. And I get that by the formula p hat plus or minus e. So that would be p hat from up here p hat was 0.18 plus or minus the e value. So this would give me 0.08. So 0.18 plus 0.08 and 0.18 minus 0.08. And this would give me 0.26 and 0.10. So my proportion, p hat, has to be between, my p-value. Remember in the notation that p hat represents a sample, capital P represents the population between 0.10 and 0.26. And looks like some bad news. Our numbers are wrong. So let's go back. 28. Okay, Z was 0.95. I think that's it. Yup, that was the wrong number right here. Hopefully you guys picked that up. Obviously I did not. 1.96. So we said Z score should be in yellow. That means right here. The Z score was 1.960. Let me put that into our calculator. Second entry. Okay, like press delete. 1.960 times. Okay, enter. This one right here. Delete that. Okay, that gives me 0.061. And then let's use that over here, because we said it was orange. Point 0.061, 0.061, 0.061. And let's see what happens. I think we should get a better answer. 0.18 plus 0.061 gives me 0.241, and then 0.18 minus 0.061 gives me 0.119. Okay, so if I probably rounded to 0.06, I'd probably get a closer answer. So what's a smaller number? I'm looking at close to a 0.12 and 0.24, which would be choice B. Whoa, too dark. Come back, come back, come back, come back to me. Would be this choice right there. So double check your confidence interval like I did, and it's good because I realized it wasn't one of my multiple choice.
The new all-purpose Inkman has arrived with all your favorite catchphrases like
It's time for game plans.
"I'm capable of doing anything you need."
I use mine as a bookmark. I use him to help teach my class.
It's time for game plans.
And for a limited time offer, you can get yourself a silly man too.